right, today we're going to start talking about phase shifts, and we've dealt with amplitude, we've dealt with period, we've dealt with some shortcuts with respect to amplitude and period. Today, now we're going to start working with the idea of phase shifts. So what we have here is we're going to do basically the same thing that we did before. We have values of theta. We're going to sub in for values of theta and solve for y. Incrementing out our values down here at the bottom. We're going to space our axis out. We have our theta axis, our y-axis. We're going to space our theta values out by 90s. 180, 270, 360, negative 90, negative 180. And then we are going to divvy those up into thirds. So go ahead and get your graph set up. We only have to stretch up to 1 and down to negative 1. And then divvy these up into thirds. So go ahead and get them set up. And then once you get your axis set up, we are going to do the equation, deal with the equation y equals sine of theta plus 30. Now within your calculator, you need to quantify the theta plus 30. If you want to do some mental math, that is fine. Negative 20 plus 30, negative 120 plus 30 is negative 90. But if you don't, that is fine also. You can clickety-clack into the calculator, but just make sure you quantify both those values. So in your calculator, you have the sine of theta, parenthesis, gives you that parenthesis, 120 plus 30, close your parenthesis out, and then you can hit enter. Go ahead and find all your values here, sub in your values of theta and solve for y. And the values you get as you read down the column should be negative 1, negative 0.87, negative 0.5, 0, 0.5, 0.87, 0, 0.87, 0.5, 0, negative 0.5, and 1. Now what I'm going to do is I'm going to divvy these up into halves and quarters, the 1 and the negative 1 also. So if I plot my points, okay, we have negative 120, we're at negative 1. Negative 120, we're at negative 1. At negative 90.87 is 0.75, so 0.87. Negative 60 is 0.5. 30, we are at 0. At 0, we are at 0.5. At 30, we're at 0.87. At 60, we are up at 1. At 90, 0.87. 120.5. 150, 0. 180, negative 0.5. 240, we're at negative 1. And at 330, we're back at 0. So if we take a look at our graph, we connect the dots, la, la, la. Here's our graph. Now what I'm going to put in on just my red here is what we have done already for the sine of theta. Our basic graph of y equals sine theta y equals sine theta is the red dashed line that we have in here. What the blue is y equals sine theta plus 30. And if we take a look, what has happened to our graph, y equals sine theta. If I look at y equals sine theta, what has happened to our graph for y equals sine theta to y equals sine theta plus 30? Well, the red, once again, is y equals sine theta. The blue is sine theta plus 30. What has happened to our graph? Well, the answer to that is everything has shifted to the left, and we have shifted to the left every point 30 degrees. No matter where my point is at, I get shifted to the left 30 degrees. And if I take a look at my graph or my equation, we have y equals sine theta plus 30. We have shifted to the left to 30 degrees. Okay, it is a slide to the left 30 degrees. What this is called a horizontal phase shift. It's called a horizontal phase shift. I will abbreviate that HPS for horizontal phase shift. Now, when you're in algebra, and we've gone through algebra and talked about graphs and slidings of the graph in the horizontal, or sliding in the graphs in algebra, what we call this phase shift in the algebraic world, we call this a translation. We had what was called a horizontal translation. And when you're talking about a translation or a phase shift, it is a slide of the graph left to right. So we're taking our graph and we're sliding it to the left and we're sliding it to the right. And this is called a horizontal phase shift. In the scientific world, they talk about phase shifts. Okay, when the sinusoidal world and isolation, oscillations and electricity that deals with waves, you're dealing with phase shifts. When you're talking about algebraic world and you slide it left and right, that's called a translation. Now, what we have slid our graph to the left by is this 30 degrees. If we take a look at our equation, we have y sine of theta plus 30. So we have the 30 there, but our slide to the left is a negative 30. So our horizontal translation here is a negative 30. Or horizontal phase shift is a negative 30 degrees. But up here we have theta plus 30. So how we convert this into an equation that we can work with, an idea we can work with, is we have y is equal to the sine or the cosine of theta minus this horizontal phase shift. Well, how do we get the positive 30 out of y theta minus horizontal phase shift? Well, if we take our equation, we can rewrite our equation y is equal to the sine of theta minus a negative 30 degrees. Because if we have theta minus a negative turns this into a positive. So what we have here then is our horizontal translations of negative 30 degrees. So if we take a look at a second one here, we're not going to go through all these ordered pairs, but we're going to take a look at our cosine of theta minus 60. Our b value is a value of 1. Our amplitude is a value of 1. So we still have an amplitude of a value of 1. We have the period is 360 degrees. But what we now have is we have this theta minus 60. So if we take a look at a horizontal phase shift, our horizontal phase shift is the value that's being subtracted from the value of 60 degrees. Well, the value that's being subtracted from 60 degrees, or from theta, is 60 degrees. Or it said the answer there. Which means all of our horizontal phase shift, or with our horizontal phase shift, all of our cosine points are going to move to now the right 60 degrees. So if we take a look at our theta axis again, our y-axis, if we get this set up, we have 1 and negative 1 on the y-axis. I'm going to count out by 90s again. 90, 180, 270, 360, and 450. And I'm going to divvy these up into thirds again. I'll let everybody catch up. We have a cosine curve. When we're dealing with a cosine curve, the question we always ask ourselves is, do we start on that prime axis, that neutral axis, or do we start at the peaks and valleys? Well, the sine curve, we always started at 0, 0, which is on the prime axis, that neutral axis there. But the cosine, what we talked about yesterday, we're going to start at a peak or a valley. Our amplitude is a value of 1. The period is still 360 degrees. Yesterday, when we talked about our cosine curve, we just started at the peak, which would be at our value of 0, we're going to go up to the value of 1. But now, since our horizontal phase shift is a value of 60 degrees, we're going to move over to 60 degrees and go up to our value of 1. This horizontal phase shift I will also talk about being our theta start value. Which means if I go along my theta axis, I have a horizontal phase shift of 60 degrees. So that's going to be my theta start value. Then I can evaluate with my cosine curve, I have to start at a peak. So at 60 degrees, I'm going to go to my peak, which is at my amplitude. So at 60 degrees, I'm going to go up to 1. Next thing we take a look at is the period. The period is the number of degrees in the cycle. Cycle is a point to another point where it starts to repeat itself. So if I start at 60 degrees, and I travel the period, which is 360 degrees, what degree measure will we be at? Well, if I start at 60 and go out 360 degrees, that's going to take me to 420 degrees. And at 420 degrees, I need to be at my peak again. Because every 360 degrees, I will be at the exact same value. Now we play our games of halves, halfway between 60 and 420. So I can take the 60 plus 420, hit my enter button, and then divide that by 2. So we have 60 plus 420, which is 480. I divide that by 2, I get 240 degrees. Okay, if I got 240 degrees, cosine curve, remember what we have? We are up at the peak. Then we scream all the way down below the prime neutral axis. So at 240, we'll be at -1. We play our games of halves between 0 and 240, which will be 150 degrees. 60 plus 240 is 300 divided by 2. 150 will be at our 0 value. And then halfway between 240 and 420. So we have 240 plus 420, and we divide that by 2. That gives me 660. Divided by 2, that gives me 330 degrees. So if I look at my graph now, here would be my cosine curve. And once again, if I just take a look at my basic cosine curve, a very basic cosine curve, all we have done is taken every one of our points and slid it to the right 60 degrees. That's our horizontal phase shift. We go to the back. Y equals 2 plus sine of theta. Now, if we're going to set up our axes, I can just go 90, 180, 270, 360, go out by 90s. Okay, we can count up 1, 2, 3, 4. Count up 4 on my y-axis. And now what we're doing is we're taking y equals 2 plus sine of our theta value. So we have y plus 2 sine of -90. Y equals 2 plus sine of 0, of 90, and so on. So go ahead and find your y values there. And our value should be 1, 2, 3, 2, 1, 2. So if we take a look at our graph, when theta is equal to -90, we are at 1. When we're at 0, we are at 2. When we're at 90, we're at 3. When we're 180, we're at 2. When we're at 270, we're back to 1. And 360, we're back up to 2. So here is our graph. Now, if I would do a normal sine curve again, as we've done in the past, just y equals sine of theta. We'd have a point at 0. At 90, we'd be at 1. 180 at 0. 270, negative 1. 360, back to 0. If we take a look at our graphs here and compare these two graphs, what has occurred with each one of our points of y equals sine of theta to go to 2 plus the sine of theta? Well, if I take a look at my graph, all we have done, is taken my graph and slid it up to this graph. And every one of our points got slid two units. So our graph of y equals sine theta, everything just gets slid up 2 units. What we call this is a vertical phase shift, which is the slide vertically of all of our points. So we're taking a vertical phase shift or vertical slide of our graph. Once again, in the geometry, we're on the algebra world. This is called a translation. And if we look, the value 2 is the value that's out in front of our trig function. So what we have here is we have now y equals our vertical phase shift plus or minus sine or cosine of our horizontal phase shift. What we'll be doing tomorrow is we'll be combining the amplitude and period in there also and changing that. But for right now, we're keeping it very basic. My B value is still value 1. My A value is 1. So the amplitude is equal to value 1. The period is equal to 360 divided by 1, or 360 degrees. So if we take a look at our last one here, well, before that, what also goes with the vertical phase shift is what I call a prime axis. A prime axis. Because what this prime axis does when you're dealing with graphing, it gives you an auxiliary axis to be able to help you and assist you in your graphs. So if we take a look at our vertical phase shift, which is a value of 2, if I would draw in another axis at this value of 2, we look at what we have with respect to this, what I call a theta prime axis. From this theta prime axis, we are 1 up from this theta prime axis. We are 1 down from this theta prime axis. So we are the amplitude up and down from the prime axis. So it sort of helps us out when we're going to be dealing with graphs, and it's going to assist us as we get more and more complicated with our graphs. When dealing with graphs, this here is the first thing that you're always going to want to deal with, your vertical phase shift. So if we take a look at the very last one here, or the next one, we still have an amplitude of 1. We still have a period of 360 degrees because we have a b value of 1. But now we have a vertical phase shift of -3. So if I take a look at my graph, we have theta and y. I'm just going to count out by 90s, and we're not going to fill in the values here. We have a vertical phase shift of -3. So this is the first thing we're going to want to draw in is a prime axis. This gives us a little bit of assistance with respect to graphing. So we're going to draw that in at the value of -3. Now this prime axis is what we're going to go up from and we're going to go down from. We're going to oscillate about this prime axis. So working with the oscillation of prime axis, we have a cosine curve with, once again, as we talked about yesterday, we're going to either start at a peak or a valley. We have nothing being added or subtracted from my value of theta. So we have a horizontal phase shift of a value of 0. So once again, as we talked about on the front side, this is our theta start value. So on our prime axis, we're going to go to the value of 0. Since we're dealing with a cosine curve, we're going to go to a peak. So from our prime axis, we start at -3. We have to go up 1 unit to get to our peak from our prime axis. 360 degrees, which is the period away, we're going to be at the exact same value again. So we'll still be at -2. Gains of halves. Now, our roller coaster starts out, this is our peak at -2, is now going to scream down below our prime axis. So our gain of halves is be at a value of 180. We have to go down to a value of -4. Now, gains of halves one more time. We have 90 and 270. We will be now on our prime axis. So here would be our cosine curve. Looking at the last one, I still have an amplitude and the coefficient of b is equal to 1. So our amplitude is still going to be a value of 1. Our period is still going to be 360. But our vertical phase shift and our horizontal phase shift, we have a vertical phase shift, a value of 2. A horizontal phase shift, the value being subtracted from theta, is 30 degrees, which means we're going to slide to the right 30 degrees. So we're going to count out by 90s again. 90, 180, 270, 360, 450. And I'm going to divvy these up into thirds again. My y-axis, I have a vertical phase shift of 2 and an amplitude of 1, so I need to make sure I get up to at least 3. I'm going to go up to 4. All right, first thing you always want to deal with is the vertical phase shift to draw on your prime axis. So at a value of 2, I'm going to draw in my theta prime axis. The second thing you take a look at, the second thing you go to, you look at your horizontal phase shift and you look at your trig function. The horizontal phase shift is your theta start value. So it tells me I'm going to start at 30 degrees. My trig function will tell us, do I start at peaks and valleys or do I start on prime axis? Well, if I'm on a sine curve, this tells me to start on the prime axis. If it was cosine, I would go to my peaks and my valleys. So at 30 degrees, I'm going to go and put a dot on my prime axis. That's where we start. The horizontal phase shift gives us our theta start value. The trig function tells us on the y-axis where do we start, on the prime axis or peaks and valleys. The third thing we take a look at is the period. Because this is where I start at 30 degrees, the period tells us where do I end at. Well, if I start at 30 and I have to go 360 degrees out to my right, I will end at 30 plus 360, or 390 degrees. And the period will give us the value where the graph will start to repeat itself again. So at 390, we'll be on the prime axis again. Now we start playing our games of halves. Halfway between 30 and 390. Once again, I can take 30 plus 390, hit your enter, and then divide by 2. So we have 420 divided by 2, we're at 210. Sine curve will be on the prime axis still at 210. Then halfway between 210 and 30 and 210 is 240 divided by 2. That gives me 120. That will take me to my peak, which will be up at 3. And halfway between 210 and 390. So I add them together, that gives me 600. So I add those to get 600, divide by 2, I have a value of 300. I will be at a valley. So here's a sine curve, our regular sine curve that gets slid over to the right 30 degrees and then up 2 units. Okay, we're sliding to the right. Here would be where I normally start. This would be my graph to start out with. I'm taking my graph and sliding to the right 30 degrees. And then up, up 2 units. Now let me do it. We go to the right 30 degrees and then up, maybe, 2 units. And that's our idea of a phase shift. Your homework, you have on page 50 or 48, 3 to 12. What we will do tomorrow is we will start putting all these things together. We'll start changing the amplitude. We'll start changing the period. We'll get a lot of practice with them. So it's not one of those things where we're going to get through this quickly because this is all new to you. But as you went through the pre-test and looked at some of the ideas from the pre-test, and now look at them as we've gone through the process here of and a couple of days of going through the material. You can start to connect the things that we did on that pretest to what we're doing here in class now. So make an effort, page 48, 3 to 12. Work on the problems. Tomorrow those will be sort of our working notes as we go forward, and we continue to basically advance ourselves in the forms of the equation. All right, everybody can get to work. Have a good day.